So we're going to switch gears a little bit, and we're going to start talking about advanced analytics within the ArcGIS platform. This includes our exciting new insights capability, raster analytics, geoanalytics, portal collaboration, and much more. And to walk us through that, I'd like to introduce my colleague in technology and in wardrobe, Jay Theodore.
Great choice, Jim. Thank you. Hi, everyone. ArcGIS is a mapping and an analytics platform, a very powerful and advanced analytics platform. Over the next few minutes, we're going to share what we mean when we make that claim. Any analytics starts with your data. Your data could be a geodatabase representing assets, networks, business data from your enterprises, all the way through real-time streams that are flowing into the system, bringing in sensor feeds, moving objects. And then, of course, there's the big data in the category of thousands of shapefiles or CSVs, or it could be HDFS or Hive. ArcGIS integrates any of this kind of data into the system. And then there's more to just bringing the data into the system. It provides context to that data. The context is essential because the goal of bringing it in is to deliver timely, data-driven decisions for you. That means understanding what's the best storage, what kinds of tools we need to provide in order for you to get the answers, and how do you visualize that. Here are a few examples of that. And of course, when we talk about big data, we're talking about the velocity of the data, the volume of the data, and of course, the variations that can come with that data. All of that is taken into consideration when we provide the context. A lot of you are familiar with our analytics in the form of spatial analysis and geoprocessing, very, very powerful. And of course, real-time streams coming in through the GeoEvent server. But what we are introducing new is the new geoanalytics and raster analysis capabilities of the system at ArcGIS Enterprise 10.5, which is out. Analysis is not complete just by itself. It's about how you visualize, how you interact with it, through rich experiences, through Pro, the web, and insights, and application built for analysis. And of course, you can automate the whole system as a scripted experience. I'd like to share the depth of the product in the sense of the ArcGIS Enterprise 10.5 architecture, the purpose-built servers that we have, and the purpose-built data stores that we have built in. So the way you'll use it is through the various data stores. So it ships with the ready-to-use data stores that are made for observation data, or feature data, or tile cache data. And of course, you can attach your own data sets in whatever stores that they are in, or you can enrich your data with Esri's curated data. The most important thing I want to focus on over the next few minutes in the area of analytics is these purpose-built servers that perform and scale for what they are intended for. Raster analytics through the image server, and geoanalytics for tabular and vector data. So when you talk about raster analytics, the steps of using it are very simple. You're basically extending the power of Pro with raster models and function chains and so on, and having it parallelized on the server. And you'll just attach your data sets to the server. You'll invoke the analysis, and then you view the results of the analysis. It's as straightforward as that. So I'd like to introduce Vinay from the raster team to walk us through how powerful raster analysis could be. Vinay?
Thanks, Jay. I'm going to be using a problem set that's defined by the Chesapeake Conservancy Group, wherein I need to create a high-resolution land cover map. Now, this typically takes a long time to process using the traditional desktop-based image processing approach. So I'm going to talk about how can we leverage raster analytics in 10.5, leverage the enterprise, and solve these kinds of problems. Firstly, Pro, it comes with a slew of raster functions out of the box, image processing algorithms which let you process, analyze, and visualize your imagery. I've created this custom function chain with a bunch of functions. Each function has an associated set of parameters, data sets associated with it. I've then saved it out as a customized function chain, which essentially creates my land cover map. Now, as I navigate around this map, I zoom and pan around this map, my imagery is processed on the fly at the scale, resolution, and extent of my view. This is useful and sufficient in most cases. Our problem set, though, as I defined earlier on, requires me to scale this processing to the level of the county or scale it to the level of the state and create a persistent data set. That's essentially creating a couple billion processing, a couple billion pixels. Pro is an integrated application with the enterprise. So just like how I ran processing using the desktop, I could leverage my WebGIS and run RAST Analytics. So I've just kicked off RAST Analytics behind the scenes, and while this goes on, I'll just switch to slides. This should give you a conceptual overview of what's really happening behind the scenes. I have a set of input WebGIS layers. I use ArcGIS Pro to define, design, or author my raster models, which are then submitted to the enterprise using either ArcGIS Pro, Portal User Experience, or developers can do the same using the REST API. Raster Analytics at 10.5 then distributes my processing to the available cluster of machines. My input data sets, they reside natively as files on disk or within the distributed raster data store. My results are then written directly back into the enterprise. It's persisted and accessible across the ArcGIS platform. Let's now switch back to Pro and check on the results. And here's my resultant layer within Pro, and it resides within my enterprise as well. Now, this time, as I zoom and pan around and navigate around my map, my imagery is stored within the enterprise. It's a persisted data set and processed a couple billion pixels in under 2 minutes. It's stored in its native resolution and at its full extent. I'll now switch back to another slide. So here's an interesting use case with an interesting set of times. Now, let me tell you, this process took me days using the traditional desktop image processing approach. My input data is the entire Penn State watershed area. It's approximately 400 gigabytes and 100 pixels of data. There's an intensive amount of processing, multiple derived data sets. I'm creating a false color composite, segmenting my imagery, classifying my imagery, eventually creating a high-resolution land cover map. My infrastructure, I've used Microsoft Azure, 10 instances, 20 cores each. The result, 100 billion pixels that was processed in 1 hour and 13 minutes, as opposed to days of processing using desktop. All right, I'll switch over to a web application. Now, we have a developer story as well. Raster Analytics has a REST API, enabling developers to build customized, focused, slimmed-down web applications. So like in this case, I have access to the complete NAPE data set as an image service. I can create dynamic products such as a vegetation index or an infrared, a color infrared product, or just like what we did at Pro, I can leverage Raster Analytics, and behind the scenes, I can kick off a Raster Analytics product. So I pick my product, specify my settings, specify the input data sets I want to use, provide a large AOI, in this case, and I create my web layer. So this just essentially kicks off Raster Analytics behind the scenes. So the key takeaway, Raster Analytics is an integral component of the enterprise GIS. It's scaled to run, it's scaled to work with large data set, it scales to your organizational needs. One of the key value propositions is time. What used to take days or weeks to run now completes within a matter of hours or minutes. Tasks or processes that were deemed impossible previously, we've now made it possible by the power of Raster Analytics.
Thanks,
Jay.
Vinay.
Back to you.
Thank you very much. So 100 billion points, 1 hour. So moving on into geoanalytics, we want to talk through two distinctly different scenarios. The first scenario is how, very similar to what Vinay showed, how can you do the same with geoanalytics? Powering it from Pro, the sequence is the same, where you attach your data set, you run the analytics, and then you can view, or you can share. And most importantly, in Pro, because you already have a rich set of tools available in Pro, you can continue your analysis in Pro. And to do that, you can start off with just a single node of GeoAnalytics server. So I'd like to introduce Lauren from the spatial analysis team to show us and walk us through. Lauren?
CenterPoint Energy has data coming in regularly, stored in the form of a series of CSV files in our big data file share. Here are over 250 of those CSV files, and they represent over 54 million power outages in Houston over an 18-month period. Now, this is just a 1% sample of that data. It's a ton of data, and it's really hard to make any sense out of it. Well, in Pro, I have access to all of the GeoAnalytics server tools. I want to start by aggregating my data. And these tools look and act like any other geoprocessing tool, except I can access data on a big data file share. The analysis is running on the server in a parallelized way. Now, in this case, I want to aggregate into a series of hexagon bins that are 2 kilometers wide. And in addition to just getting the number of incidents in each of those bins, I also want to get some basic statistics about the duration of those outages. So I'll sum the total number of outage minutes and get an average outage duration. And finally, I'll set my output coordinate system. Now, aggregating 54 million points is going to take about 4 minutes. So in the meantime, let's go back to Jay.
So when Lauren takes a break, let's go to the next scenario, which is a very distinctly different scenario. Here we have a case of GeoEvent with real-time feeds flowing in. So it's a fully live system where there's hot data flowing into it, getting recorded as observational data, and you have GeoAnalytics that can perform batch analytics on this system. It's the same GeoAnalytics server, except that you have 5 nodes in this scenario. So to walk us through this, I'd like to introduce Philip. Take it away, Philip.
Thanks, Jay. As Jay said, this is an ArcGIS Enterprise system that's been set up with GeoEvent Server and is ingesting a continuous real-time feed from FlightAware. Here, we're looking at the stream over North America. The system is storing flight data positions for airplanes currently in the air across the globe, and observations are streaming in at a rate of several hundred events per second. We're storing a sliding window of 7 days' worth of data, or approximately 100 million records. On this map, you can see the real-time data aggregated into hexagon bins. This allows us to quickly visualize the incoming data and ensure its validity. At this small scale, we can't see very much, but we can see the flight density is higher around the airports, and this, of course, makes sense. As we zoom in a little bit further, we can start to see other patterns emerge. Here, I've overlaid the FAA's en-route maps, and we can see how the flight patterns follow those highways in the sky. Now, we used GeoAnalytics Server to take the real-time data and work with the collected. We aggregated the flight data positions into bins, showing the flight density. Let's take a look at an airport with an interesting activity pattern. Here, the airport in Memphis, Tennessee, which serves as the main hub for FedEx. We can see in the early evening how there are relatively few flights, but by 10 p.m., things kick into high gear as airplanes arrive from the north and depart from the south at high volume as your overnight packages pass through. In fact, between the hours of 10 p.m. and 7 a.m., Memphis Airport becomes the busiest airport in the world, and it's FedEx time. Using space and time, we can easily see this unique flight pattern. And this is just a few days' worth of data that I've dynamically filtered out from the total aggregated data set. Next, we took our full set of flight data with flight identifiers and used the Reconstruct Tracks tool from GeoAnalytics Server. Going from 100 million records to 600,000 flight tracks took just under half an hour. Now, looking at the flight tracks, the FAA gave us a challenge to help optimize our nation's airspace. So we want to take a look at just the US flights. The US airspace is divided into multiple air traffic control sectors that we can see here in ArcGIS Pro with a black outline. Every time an aircraft leaves one sector and enters another, there's a handoff between the aircraft and the responsible air traffic controllers. This handoff involves a lot of communication, and we want to minimize the number of handoffs. So I continued my analysis in ArcGIS Pro and took the flight tracks that we just created with GeoAnalytics Server and ran this geoprocessing model. I split the flight tracks by the flight control sectors, and now we can identify locations where there's the potential to redefine the existing flight control sectors, such as this one. Here, it looks like there's the potential to move the boundary of an existing sector a bit north and avoid several hundred handoffs every single day. In short, I showed how we could work in ArcGIS Enterprise with large volumes of streaming data, ingesting 100 million records from FlightAware using GeoEvent Server. We saw how GeoAnalytics Server helped crunch through that data and create smaller data sets suitable for further analysis. And looking at the data in aggregate, we could see the flights and patterns that mattered to the FAA. And of course, all of these things are available to you as developers as well. All of GeoAnalytics is exposed through the REST API as a regular geoprocessing service that you can consume from all of our APIs and SDKs. Thank you. Now, Lauren, how are you and your analysis doing?
I'm doing a lot better. The analysis went really well. It finished 4 minutes, 0 seconds. You can see it finished at 10:01, so just a couple minutes ago. And aggregating that 54 million points into a grid, immediately we start to be able to make a little bit better sense of it. We can see where we have more outages and less outages, and the pattern matches up pretty well with population density, which we would expect, more outages where we have more people. We can also start to explore some of those statistics that we calculated when we ran the analysis. So instead of looking at count, I could switch to the total number of outage minutes, which, again, matches up pretty closely with population density. No surprises there. We could also explore the average outage duration. Now, this tells us a very different story. Though we can see those places that have had longest durations of outages are those places in the more suburban and rural parts around Houston. And this is information that Centerpoint can use immediately to prioritize improvements to service levels. Now, in addition to analyzing all of the outages, I also ran the Find Hotspots tool on 42 million momentary outages. And in about 6 minutes, it created this map. Now, momentary outages are brief outages that are often caused by vegetation. A tree branch brushes up against a power line and trips a breaker. Here we'll focus in on the hotspot in the center of Houston. To better understand the spatial pattern and to take advantage of the 18 months worth of spatiotemporal data that we have, I ran the Create Space-Time Cube tool using GeoAnalytics. And in 5 minutes, it created this space-time cube, aggregating my data into space-time bins and showing us where we have, how many outages we have in each one of these 1 kilometer, 1 month bins. Now, just looking at the raw cube, I can start to see things like fluctuations in patterns in both space and time. And because I've created the cube, I can also take advantage of powerful desktop analysis tools, like the Emerging Hotspot Analysis tool, which runs a space-time cluster analysis on my cube and further boils down that data to reveal trends. In this case, showing us 2 locations that are hot for the first time in 18 months, alerting us so that we can act quickly and focus our resources effectively. And these are just a few examples of how we can use GeoAnalytics to extend our desktop analysis. Back to you, Jay.
Awesome, Lauren. Great job. So that was perfect examples of how you could use geoanalytics in two extreme cases. Philip showed the second scenario, which is real-time and big data analytics, large volumes of data. It had 100 million observations over a 7-week period that was getting purged over 7 weeks old, and reconstruct tracks. And Lauren, of course, showed Pro and the power of it when you sift through 54 million points accumulated and finding your right answers. So the science of spatial analysis has advanced dramatically thanks to compute, data storage, and visualization advancements. They all work together, and ArcGIS Enterprise 10.5 has it all. But this is a dev summit. You're all developers, most of you at least, and you want to see some code. How do you drive this from an API? So today, we're going to share a lot about the new Python API. You go through the same sequence, except that it's fully automated. You can use Python libraries. You can use notebooks. I better stop talking about this and let Rohit show us what you can do. Go ahead, Rohit.
Sure. I'm so excited to be here and show you the ArcGIS Python API. It's a new API to the ArcGIS platform, super easy to use, and it's great for data exploration. So analysts and developers are going to love it. So let's see how you can use the ArcGIS Python API to do mapping, visualization, and analysis of crime. And as Jay said, it's a 3-step process that starts with your data, goes to analysis, and then your results. And in many cases, the data that you want to use, it might be locked up in different file formats, might be embedded in web pages as tables, it might be inconsistent, it might not be geocoded, even though it has a spatial aspect to it. And I'm using similar data. It consists of about 1 million crime incidents from the city of Houston for the past 8 years, spread across 100 Excel spreadsheets. But that's not a problem. I can use Pandas, which is Python's data access and analysis library, to automate the task of fetching that data and read it in as a data frame. So looking at the raw data, you see that I need to clean it up. The number of offenses, for instance, are spread across many columns. It has many null values, and so on. So data scientists often spend more than half of their time in collecting, cleaning, and enriching their data. And Pandas can help make this painstaking process fast and efficient and repeatable. So here I'm cleaning up that data, and so once it's cleaned up, that's what it looks like. It contains the date, hour, and day of week of the incident, the category of crime, the number of offenses, the beat, and an address, which brings us to geocoding. I'm using the high-performance, parallelized geocoding tools that we just released at 10.5 to quickly analyze and batch geocode this data and load it up as a spatial data frame. The spatial data frame is an upcoming capability of the Python API that lets you work with spatial data as if it were a Pandas data frame. It's very powerful. We are adding geospatial operations to Pandas, as well as the ability to read and write to shape files and file geodatabases that I'm doing here. So let's see how you can now connect this data to your GIS. You can add and publish it as feature layers, or you can connect it to geoanalytics by adding it as a big data file share. Once you do that, the data sets within start showing up as items in your GIS, and these items have layers that you can use for your analysis. OK, the hard part is now over. I now want to visualize the crime layer that I had published by adding it to map widgets within the notebook. And in the map on the left, I've added this layer, and there are far too many points to make sense of. I can also use smart mapping, and here I've specified that in the map on the right, it should use the heat map renderer to show areas of high crime density. I can use the spatial data frame in combination with charting libraries like matplotlib to see patterns like what is the distribution of the crimes and how does it change by the day of the week. So we start seeing patterns such as that the number of murders increases during the weekends and the burglaries tend to go down. We can also see the distribution by the hour of the day and how it's different for each crime. But that only tells a part of the story. I want to be able to map out these crimes using the powerful analytics provided by the ArcGIS platform. And for that, I'm using the Find Hotspots tool provided by GeoAnalytics. And what's great about the Python API is that you can automate the task of finding these hotspots for each category and for all years in your data set. And you can generate these hotspots and persist them as information products in the form of web layers that you can use for your analysis and visualization. So I've done that, and I'm now ready to visualize it. And now I'm comparing the hotspots of burglaries with those of auto thefts. And I see that each crime has a different spatial distribution. Let's see what the hotspots, how they change over time. And here I'm comparing the hotspots of auto thefts over the past 3 years. And what's striking is that the hotspots are very similar across the years. The hotspots of yesterday are the hotspots of today and are likely to be the hotspots of tomorrow. And I can use this information to allocate resources and identify areas in need of intervention. And while the field of crime analysis and mapping is quite deep, and I'm just getting started here in my notebook, I'm sure you can all appreciate that there's an incredible wealth of tools available at your disposal to do an analysis like this. You can combine the data science and machine learning libraries from Python with analytics and content from the ArcGIS platform and do amazing things. Thank you.
Thank you, Rohit. That was a nice tour of how you could drive analytics through the API. We're also very excited to announce 2 new things about the API. The first one is you can go to the dev site and check out the live notebooks. You can experiment with the API yourselves. And we're also making it available through a Docker container that you can download and run the entire SDK with a notebook server in there. So thanks a lot for listening to the analytics section.